All right. Good morning, everybody. We are here to kick off our first meeting for fiscal year 2022. Hopefully everybody can hear and see everything appropriately. If not, put something in the chat box if you're having any problems. So let's get rolling. Welcome back to the meetings for the West Central Ohio Safety Council. We're so happy to have everybody back and to be back in action, and for each of you that is joining us this morning. Thanks for being here. I'm Deb Katzmeyer, manager of the Safety Council, for those of you who don't know me. This is a list of our steering committee members, and they help with all aspects of the Safety Council program, most especially choosing our topics and helping to find good quality presenters. Without them, none of this would be possible, and I appreciate them very much. So I just wanted to take a moment to recognize them here. Please use the chat function to network, and questions can be asked using the Q&A feature. All attendees will receive a recording of the webinar along with any pertinent attachments and slides. If you have any ideas for topics or presenters, please drop a message in the chat box. Just some ongoing changes with BWC this year. All of the Safety Council meetings will be conducted virtually through June of 2022. Again, rebates will remain suspended until we're back in person. There will be no collection of semi-annual reports, and there's also no CEO attendance requirement. BWC has taken it upon themselves to do a couple of mega meetings, which are more at a high level that can appeal to all audiences. So please take note of the dates listed here for October and April. And because of that, our Safety Council will not have a separate meeting in October or April. You'll get more information about that as those dates approach. So something we're really excited to roll out is our new attendance incentive program. Each person in attendance at each meeting will be entered for a drawing for $100 in chamber gift certificates. The grand prize will be held in June, and there'll be a multitude of multiple choices to win. For example, if you attend 8 meetings, you get your name in the drawing 8 times. So it's beneficial for you to come to the meetings. Just a quick glance at our schedule through the end of this year. As you'll see, we have some great topics coming up and some really wonderful presenters. So we'll hope you'll be able to join us. And next we have Dean Bidlack. He is our BWC representative, and he's here with us today to share some BWC updates with everyone.
Good morning, everyone. I haven't retired. I'm still here. I just want to let you know the Bureau of Workers' Compensation field staff is in the process of figuring out how we're going to present our services the most efficient way out to the employers. So with that in mind, we have now developed some micro videos that you can get on our website. We still do virtual servicing for industrial hygiene, ergonomics, myself, and safety. And we can virtually conduct some of our meetings and actually some of our smaller consulting. We will end up being a hybrid in some shape or form. We're not sure exactly how we're going to do that yet, but we will be coming back out in the field in the near future as they work out those rules, how they want us to do that. It helps us cut down some of our driving time when I can go to 4 to 6 companies a day instead of 1. We still have virtual classes and webinars. Those are available to you to take at your leisure. Those can be used for credits for some of our discount programs. So I would encourage you to use those as many as you can. That is the driving force for us. Folks, we can have 150 to 200 people in a class that way instead of 20 people in a face-to-face meeting. So that's one of our rationales why we should better do a hybrid. We have a special webinar coming up today at 11 o'clock for small businesses, how safety affects the small businesses. We would like you to take advantage of that if you are able to. And that's also available on our website. The industry-specific safety programs, we've helped cut down some of your paperwork. Now we're just going to have some benchmarks for you to follow up on our visits, and you'll get back to us and tell us that you've fixed those items that we've identified, and we will not need to have some of the paperwork demands as in the past. We've changed some of our written safety program templates to help you get started with your safety programs for those new people. We've got safety talks available that you can use, and our special grants. The regular safety incentive grant is not going to be available immediately. That will come on later on in the fiscal year probably. But in the meantime, we still have our trench safety grant, our firefighter exposure to environmental elements grant, our school safety grant, our employees working with the disabled or developmentally disabled people. That's still there. And we have a COVID indoor air quality that we're still also offering. So we want to make sure that people are aware of those. Take advantage of those as much as you can. Use as much money as you can out of the fund and put it to good use. Make it safer for all your employees. And last but not least, don't forget OSHA now has an emergency temporary standard for COVID. It only affects certain industries. So it's a good rule of thumb for you that are not in that industry to at least use it for a place to start. And I encourage you to do that. Feel free to give any of the safety consultants that you dealt with in the past a contact. It doesn't matter. We will do what we can to provide the services that you always had in the past, and we will just do it in a little different fashion. So we're still here, and we're out there to try to help you make your workplace safer for everybody involved. And I thank you very much.
Awesome. Thanks so much, Dean. We're glad you're still on the scene, just kind of behind the scenes. Oops. And now that we've covered some of the basics, it's time to move on to this month's topic, which is electrical safety. Whether you deal with it at work or at home, there's so many factors, safety factors that each of us should know when it comes to electricity. And I'll be turning things over here in a moment to our speaker, Bob Momeny with the Safety Council of Northwest Ohio. And he'll be talking about electrical safety, obviously. He is the interim director of operations and the chief training officer at the Safety Council of Northwest Ohio. And he brings with him 20 plus years of experience in the safety industry. And without further ado, I will turn this over to Bob. Good morning, Bob.
Morning, Deb. Thank you. Thank you. You're going to have to allow me to share my. Oh, you've already done that. You've already done that. Super. Let me do this there. Can you on your screen?
There you go. Yep. Now we can see our presentation.
Oh, super, super. Okay. Everything's going well so far. Good morning. Good morning. And thank you for the invitation. I'm so happy to be here and honored to make a presentation for you. Your maiden voyage, so to speak, in the virtual format of meetings. So I'm honored to be here with you today. As Deb mentioned, my name is Bob Momeny. I'm with Safety Council of Northwest Ohio up here in the Toledo area. Our office is actually situated in Northwood. And I've been here with the Safety Council for 21 years. And also my other job, so to speak, is what's called a part-time trainer for the Toledo Electrical JATC, where I've been over with them doing night classes for apprentices and for journeymen since 2007 with the JATC. So that's a little bit of my background. We'll get right into this. This is a great topic, and I was thrilled that this was that I was asked to present on this. In the workplace, I always think this is one of those great topics because most people are afraid of electricity. They don't want to be around. They'll walk the other way from it. They don't understand it. They know it's a danger, and they'll walk the other way from it. You see a lot of things over my time in safety over the years of people that will walk right into a hazard, know it's there. They'll operate a machine without a guard on it into a situation not wearing their PPE or something like that. But when it comes to electricity, a lot of times people, they identify it and they say, I don't want to be a part of that. Just, I'll walk the other way. I don't understand that. I know it's bad and I'll keep my distance from that. So that's always a good thing. Just keep yourself distanced from that hazard. So to start out with here, just some things about electricity. On average in our country, there's 5 workers that are electrocuted every week in our country. It's one of what they call the fatal 4 in construction, one of the 4 leading causes of fatalities that happen out there. 12% of our young workers, their fatalities are caused by electrocution, which I always think is kind of an interesting number. One of my videos that I'm not going to show you today, I just don't have the time for it, is a young lady in a workplace that was caught on surveillance, and she receives an electric shock. It's not electrocution, it's not killed, but she receives an electric shock. And during the time, the summertime and kids getting out of school, whether it's high school or college, they come back. I got 2 in college that have come home and they're working right now. And the one thing that I've talked about here with our local OSHA office in Toledo is when these young workers go out for summer jobs that they get sometimes very little training and very little training on how to identify what hazards are. And I always think that's interesting. 12% of the workplace fatalities for our young workers, it's electricity. That next bullet point, which is also very, very interesting, about it doesn't take very little electricity to cause harm. Now, over my time, over my years of doing this, I've heard people dismiss or seem to dismiss the term low voltage. Oh, that's low voltage. That won't cause you any harm. You might feel a tickle or a prick or something like that, but that's low voltage. That won't harm you. I'm going to kind of table that right now, and we'll come back to that later on when we talk about that. Also, the number 1 cause of accidental fires in business in this country is electrical. So it's a significant cause for that as well. There is 2 types of electricity that we have. There is what's called static electricity and dynamic electricity. And I like to talk a little bit about the static electricity because it's a hazard just as much as the dynamic electricity can be. Static electricity and what it is, there's a buildup of an electric charge. And I got a video that's coming up. It's a wonderful video that I'm going to share with you that I've had for quite a long time, but it's a great teaching video that I can show you about static electricity. That's a little video clip, surveillance clip that's coming here. You get a buildup of electric charge on the surface of some type of material, but it's not moving. The dynamic electricity is our moving electricity. Static electricity doesn't move. It doesn't come from rubbing materials rubbing materials together. Like the graphic that I put down there, you take a balloon and you rub it, and then we used to stick it on the wall on our house and things like that. And I think sometimes people think, well, statically, you start rubbing things together, that's where the static electricity comes from. And it's not that way. What it's doing is it's transferring electrons from something that's positively charged to something that is negatively charged. So I just did this morning, included this in here. Let's hope this works. And it looks like it's working. So what you see here, of course, is a surveillance video at a gas station. You can see a young is going to get out of her vehicle, and she is going to select her gas, of course, put her card in, open up her gas tank. Making your selection still. And so now she puts the nozzle at the gas. Now, if you've ever noticed at the gas stations, there is typically a warning sign there at the gas pump about not getting back in your vehicle. And the reason for that is because you watch that young lady. I'm going to see if I can kind of pause this. Yeah. So she got back in her vehicle. She moved around in her vehicle, okay, moving back and forth. She gets out of her vehicle. She's playing with her sweater. But what has happened is that she has built up charge. Moving around in that vehicle, on that seat, playing with the sweater, all these things, she has built up charge. and she hasn't touched anything yet that is negatively charged or grounded in this case. The first thing she's going to touch is that nozzle for that gas pump. And when she does, she's going to transfer the ions, and there you go. So fortunately for her, it looks like the pump had shut off. She's just burning the vapor out of the hose at that point. It doesn't look like she was injured, but it was the poke that you get when you touch a door handle or touch another person or something like that. We need three things for a fire. We need heat, oxygen, and some type of a fuel source. And we had all of that right there. The heat, of course, came from that poke, with gasoline having a very low flash point. So that's static electricity. Let's talk a little bit about the dynamic electricity. Now that's moving electricity. That is flowing from one place to another. Typically requires a generating station someplace, traveling through a conductor in a closed circuit. So back in the 1980s, late 1980s, I worked for the Toledo Edison Company at the Bayshore Power Plant here in Toledo. And at Bayshore, we were a fossil fuel plant, coal-fired. And so I'll give you the electricity 101 and how it's made, at least from a coal plant. The coal was brought to us at Toledo Edison through a rail car. The rail car would be emptied in what was called the dump house. The coal then would be transferred from the dump house by conveyor to the power plant. Inside the power plant, the coal was distributed to silos that funneled down to pulverizers where the coal was pulverized. The pulverized coal then was used by the turbines to create the electricity. It was sent out of the power plant to a substation just outside. That power would be stepped up to high voltage, and through transmission lines, it would be sent through the power lines to substations, where that voltage then would be stepped down to a lower voltage. From the substations, it would be distributed throughout neighborhoods in the areas of the substation to poles where there was a transformer. Again, the power would be stepped down again to another lower voltage before it was brought into a home or a business. When it was brought into the home or business, it would go to a breaker box or fuse box. From there, it would be distributed around the home or business to outlet switches and fixtures. When something was plugged in or a switch was turned on, that electricity was released to power something, a light bulb, a computer, a fan, something. The electricity would do work. When the work was done, that electricity would return back to the outlet or back to the switch, and then ultimately it would be grounded at that point, and that would complete our circuit. So there's electricity 101. Some terms here. Current is that movement. It is measured in amps. I'm going to talk a little bit more about amps as we go along and the importance of this. The circuit is the complete path of the current, exactly what I just talked about with the electricity and ultimately getting back to ground. The resistance is how easy or difficult it is for that current to flow. A conductor is something that is, and there's good and bad conductors. Good conductors of electricity have little resistance to that flow. Metal is a good conductor of electricity. Water is typically a good conductor of electricity. And of course, the human body can be a good conductor of electricity as well. Grounding is our connection back to Earth. That's our protective measure. The number one OSHA violation out there when it comes to electricity is a grounding violation. So I'll give you some examples of that as we go along here. And then insulators, something with some high resistance that in the end kind of protects us. So if you think like an extension cord, we'll use that. There's wiring inside the extension cord, but it's wrapped with plastic or rubber. That's our insulator so that we're not exposed to the hazard. When it comes to electrical injuries, we have four main types of electrical injuries. Electrocution is death by electricity, where somebody has been exposed to electricity in the amount or over time, and they are fatally injured because of it. Electric shock is, by definition, injury by electricity. There are electric burns out there, which are some of the worst burns that anybody could experience. And then there's an indirect one, which is the falls, which we'll talk a little bit about that as we go along as well. So how does somebody get an electric shock? Well, what happens is you get current that passes through the body. Typically what happens is somebody is in contact with or in close contact or direct contact with something that is energized, and they're also in contact with something that is ground. So if you can imagine, maybe if you were, when I do this in a live classroom, typically I'll put my hand against the door jamb, and I'll hold a wire that is not insulated. I say, well, if this wire was it was energized, it wasn't insulated, it would pass through my hand, through my body to where the door jamb is, which is grounded, and that would complete that path back to ground. And I would, at minimum, get an electric shock because of something like that. It could also happen by somebody touching a energized wire, and then there is a difference, and that difference is a wire at a different voltage. That can also create an electric shock as well. How bad that shock can be really depends on three things: how much, how long, and path through the body. So I'm going to start with how much, first of all. How much energy, how much electricity, how much current, I should say, is flowing through the body is measured in amps. How long somebody is in contact with something as well also can determine ultimately in the end how bad the shock is going to be. And then the path through the body. What path is that current going through the body? So the diagram that you see on the screen is really a good diagram. I have another little video that I show many times where I have a person that actually grabs a hold of an energized wire. He's actually standing on top of the train. Maybe some of you have seen it before. And he's standing on top of a train car, and he grabs an energized wire. And in the matter of a split second, the current passes right through his body, through that train car, and he is electrocuted. It's a very graphic video. I won't show it here. But it's going in the diagram there. Of course, you see the current is going through the body from the hand, which the energized wire at the beginning, and exiting through the body down at the foot. And of course, that current's going right through the body, especially through the heart area. So I mentioned about low voltage and doesn't mean it's a low hazard. I said I would get back to that. So here we go. So currents anywhere above what we call 10 milliamps can cause muscles to freeze up. I always give the old cartoons. You used to say in the old cartoons where somebody, the coyote or Bugs Bunny or somebody would grab a hold of the wire and they couldn't let go of the wire. Well, in reality, that's what happens if there's enough amperage there. The muscles freeze up and somebody can't let go. So at 10 milliamps, so a milliamp, remember a milliamp is 1/1000th of an amp. That's a milliamp. 1/1000th of 1 amp. So if you think for your homes for a moment, your homes, your breakers, they are at either 15 or 20 amp, depending on what room you have. 15 or 20 amps. This is a milliamp we're talking about here. So 10 milliamps, 10/1000th of 1 amp is enough to freeze the muscles. Anything great more than 75 milliamps or 75/1000ths of an amp, this is where this low voltage that we talk about, this becomes important. Because at 75 milliamps, what can happen, exactly what we have here, where that current goes through the heart. And it can cause the heart to go into ventricular fibrillation, it can cause cardiac arrest at 75 milliamps. So you think of a power drill, see the bullet point on the bottom, a power drill that you plug in. Standard 2-prong, plug it in the wall, electric drill. That's 30 times as much amperage is needed to cause somebody to go into cardiac arrest. I got a diagram of reverse polarity coming up where I'll use a drill where this will also hopefully make some more sense. I did mention the burns, that the most common shock-related injury out there is the burns, typically on the hands, because that's where the work is being done. But electric burns are, I always consider to be some of the most severe burns that are there. When you think of a thermal burn where you touch something that's hot, or you spill some boiling water on yourself, or even if you've been out in the sun too long, that's a thermal burn. It's a surface burn. Or a chemical burn. You spill some chemical and it burns me. That's a surface burn. But an electric burn, the current goes through the body. So we may have a burn like you see in the picture there, where you may have an entrance wound where the current went into the body, where maybe somebody touched something that was energized. And on, let's say they were grabbing a hold of something with their other hand and the current left their body. So you may have a burn there where the current left the body, but all the way through the interior of the body, that current's burning really from the inside out. And it's really something that's not very treatable, where other burns, there's more treatment for that. So it's very serious and very painful, of course. And to throw in there one more thing, depending on the amount of voltage that you're talking about, where that current leaves the body, you could have what's called a blowout. So on that hand right there, if that's the hand where the current left the body, if there's enough voltage, which is force, you could blow the fingers off the hand or the hand off the arm, or maybe even the arm off the body in a situation like that. The electric burns are very, very serious. Another thing that is what we call, and you saw this in the earlier slide, was the indirect injuries are the falls. A lot of times, if you look in your workplaces, electricity is elevated. Like junction boxes, things like that are elevated in the workplace. And so somebody is going to have to probably get out a ladder or maybe get on a lift or something like that when work has to be done on these things. And if there would, say, be a shock, and I've had plenty of electricians over at the JATC over the years who have told me about situations where they've gotten a shock and it knocked them off of a ladder. And that's where the indirect part of it could be. The shock may not ultimately in the end cause too much of an injury, but the fall part of it, coupled with that, may. Here's some hazards and some things to look for back at your workplace or maybe even your home as well, and how to control some of these hazards as well. Unsafe equipment, unsafe installation, workplaces made unsafe in the environment, and just simply safe work practices. So what you see here in this picture, of course, you see a lot of loose wiring that's there. You see a lot of cords that are taped up. You see cords that are taped together. There's no protection for those cords. It does look like there's extension cords that are plugged into hanging outlets, so the outlets aren't in the boxes. The cords, depending on how long they are there, may kind of meet the definition of what's called permanent wiring. So there's a lot of hazards right there in just that one little picture. Those outlets, I don't know if my pointer were those outlets that you see right here, if you can see that, they need to be in a box and secured in a box. They need to be grounded as well. I don't know if they're grounded. Cords like this aren't supposed to be taped up to our extension cords like that as well. And like I said, depending on how long the extension cords have been plugged in, that may be a hazard as well. There's something that's not all that uncommon to see out there. I got a better picture of one coming up later. But just simply boxes that don't have covers on them, where somebody has gone into a box at some point in time, maybe ran a new line in there, something like that. And then they forget to put the cover back on the box, and it gets left like that. And we have that exposed wiring. That's a shock hazard and a fire hazard. We'll see that like that right there. Plus the connections as well, again, with placing covers. Again, we have exposed wiring that's here where somebody could maybe reach into there, a tool could get into there. Anything that is live electric equipment and it's 50 volts or more, it has to have cover or be in a box or somehow separated maybe by guards so that people don't get into it and have contact with something like that. This is one of my favorite pictures I have as part of my presentation. There's two things that are going on right here as far as a hazard. I'll start with this one right here. And it is wired directly to our breaker box.
Oh, we might have lost Bob here for a moment. Well, he's still there. So hopefully he'll be able to pop back in here and see let's see. Sorry about that, guys. You Gotta love technology, right? So, okay. Bob, where are you? All right. All right, I apologize, you guys. Just hang tight for a second, and I'm gonna see if I can find out what happened to Bob. Go. It looks like Bob's getting back.
Are you there?
Yes, we're here. Sorry we lost you.
Yeah, okay, well, those things happen. So, all right, well, I'm gonna get back to, hopefully where I was here. Do you see my slide there?
Yes,
Yeah,
yep, everything looks good.
Oh, good, all right.
Yes.
Okay, so a little minor hiccup there. So what I was saying was this is this Romex going into this box here and wired directly to a box. That's permanent wiring. That's not a temporary, that's a permanent wiring. And that needs to be protected. It needs to be in conduit and protected like that and not left like it is with this more flexible port. This here up at the top, these knockouts like this, I always consider that when I look at something like that, if I go to a business and I see something like that, I always tell them, be very, very cautious of something like this. Look at, if you're going to take a cover off of a box or panel, always look at the sides, make sure that there's nothing as far as the knockouts that have been opened up on there. And it's such a hazard to me anyway. People look at that and say, well, maybe somebody could reach in there, get their finger in there and get a shock or something like that, which is true. But here's a bigger issue that I've run across a couple of times. And that is when that is left open like that, depending on the environment, you could get dust that accumulates in something like that. And then now somebody's going to come along, they're going to take that cover off that box. When they take the cover off that box, if they disturb that dust that may have accumulated in that box and that dust falls and it causes the contact, well, what can happen is you can have an explosion. And somebody, of course, is standing right there in the blast zone when that comes out of that box. That's your arc flash. And so I always tell people if there is, first of all, they shouldn't be going into something like that that's energized anyway. It should be de-energized. Next thing is that if they do have to take a cover off a box like that, they should always check and make sure that there's no openings in something like that. Also the top of it. How long has that box been sitting there? Dust has accumulated on the top of there. They take the cover off of there, and again, dust could fall into that box when they take that off. There was actually a fatality that happened down in the Dayton area where exactly that same thing happened. Took a cover off of a box. There was dust that accumulated on top. The dust fell into the box when he took the cover off, and unfortunately was fatally injured. So it does happen. That's probably your more common things that I've seen out there where these boxes don't have the covers on them. The knockouts that you have on here are left open as well. So we need a cover on this box. We need to have plugs that are put in here so we don't have open knockouts in there. And that controls our shock and fire hazard. This is another hazard that I think sometimes gets overlooked in business and at home as well. That's your overhead power lines. People still continue to fail to look up. People with, at home doing things like trimming trees, they get a pole saw and they start trimming trees and they got the service drop from the pole to the house going right through the tree and they have potential for contact with something like that. Or setting up a ladder next to a service drop for a building or a home, and it's maybe a conductive ladder. They're using an aluminum ladder. And remember, with electricity, it doesn't have to be in direct contact close enough, depending on the voltage. That voltage can jump and it can energize maybe an aluminum ladder that's sitting directly on ground. That person becomes part of the path to ground and they will get at least an electric shock, if not more. The rule of thumb with anything as far as overhead power lines, the minimum is always 10 feet. always 10 feet. And when it gets into higher voltages, then that distance has to increase because there can be an arc within 10 feet and something gets energized. So always 10 feet away, and you always have to keep into consideration their sway. You get some wind, lines can sway. Them in a lift or something like that, or scaffolding that can sway because of the weather conditions, and I could get within that 10 feet. Also posting warning signs, reminding employees that are working under power lines that there is overhead power lines that are energized, so to warn them not to work with anything elevated in that area. Make sure that any of your equipment is non-conductive equipment. And then they have proper protective equipment as well, personal protective equipment. As far as inadequate wiring, I got a couple of show and tell things. I'm going to save them for the end. I was going to kind of bounce back and forth, but I think I'm not going to do that just for fear of losing everybody. So I'll hold that to the end. One of the things over the years that I think people have dismissed that I have found is that if I have let's say an extension cord and I'm pulling too many amps through my extension cord, that extension cord will warm up. But I think over the years, people have sometimes have dismissed the idea that, well, a cord can't get hot enough that it would start a fire. And that is absolutely untrue. If I'm pulling too many amps through a cord or through a wire, and that wire gets hot, and I have something that is combustible, pallets, cardboard, things like that, that may be laying on top of that wire, absolutely, there's enough heat that could be generated there that could cause a fire. One of my favorite newspaper articles that I saved from the Toledo Blade over there is a company that exactly had that happen, where they had a exhaust fan that was plugged into an extension cord, and they left the building. It was after hours, but that exhaust fan had been left to run, and the extension cord was not sufficient to carry the load that was going through it. It got hot and it caught this cardboard on fire and caught the building on fire, which the fire department had to respond to. Of other things here, you see that we have wiring here that is not in any type of insulation. It's wired to a plug, but it's not in any insulation or covering, so that needs to have a cover on it. Here we have a cord or a plug, excuse me, has been separated from the cord. Most likely something like that happened where somebody's not pulling the outlet or the cord part out of the outlet, but they're pulling the wire part out. And eventually what happens is that plug will separate from the cord and it exposes the wiring. As far as if I'm using things like extension cords, I want to be aware of things where they could cause a hazard or be damaged, like doorways, going through windows, things like that. Not a good idea to, somebody may say, well, you know, I want to secure this. So they'll secure it by stapling it to a wall or a baseboard or something like that. That's not a good idea because that, of course, can break through the insulation on the wiring as well, or through the jacket on the wiring. So stapling's not good. There are cable holders that are there, but again, if it's an extension cord and if I'm doing something like securing it like that, that's probably constituting permanent wiring.
Hey, Bob. Bob, sorry to interrupt. We did have a question from somebody. They asked if there's certain items that should not be plugged into an extension cord, such as an air conditioner.
Yeah, and that goes back to what the extension cord can hold. So I'm gonna stop this here. Just because the question's there, I'm gonna stop this and hopefully we'll get back. You can guide me on this here, Deb. Okay. Do you see me right now?
I see you and I see your
Or you
full
see my-
presentation. Yeah.
Oh, you see me? Okay, good. So what I have here is, here's a lead cord, okay? Simple lead cord that you buy at the checkout stand at like the supermarket, okay? So if I'm gonna plug an air conditioner into this, what's important to know is how many amps that air conditioner is rated for. And if I'm gonna plug that air conditioner into this cord, so let's say, just for the sake of argument, that my air conditioner is 13 amps, okay? Now, if I'm going to plug that into my wall outlet, that'll be fine in my home, because if it's in a living room or bedroom, that breaker that services that's going to be 15 amps. So I'm not overloading anything. But now what I have to do is be aware of and concerned about something like this. What is this cord rated for? So on my cord here, you're not going to be able to see this on here, but there's some writing on here. And my cord, the one that I'm holding right here, says it's rated for 125 volts and 1250 watts. Some cords will tell you exactly how many amps this can handle. This one doesn't. So you got to do your little mathematics on something like this. So I got 1250 watts and 125 volts. If you always remember that watts divided by volts will give you amps. So if I have 1250 watts and 125 volts, if I divide that, this is a 10 amp cord. And if I'm going to pull 13 amps to a 10 amp cord, what's going to happen is this cord is going to get hot. And eventually, if it's laying on my carpet or I got to throw a rug over it and I'm powering my air conditioner, this cord's going to get hot. So it's very, very important that you want a cord that is going to be able to handle the load that is being drawn through it. So I hope that answers the question on that, because yes, it is very, very important.
Thanks, Bob.
Sure. Is my slide back up now, or do I have
No,
to stop?
there you go. Now it is.
Okay, very good. This is another thing that I wanted to just kind of chat here for a minute. I had a person in class that said, I got a lamp at home, and when I go to touch the lamp, I always get a shock off of the lamp. And I said, well, with that lamp, he said, I'm just, the lamp's no good anymore. I got to throw the lamp away. I said, well, look at the lamp for just a moment. It's an old lamp. Look at the plug. Your plugs nowadays will have your prongs on them. You'll have a big side and a little side. The little side should be your hot one. But those old plugs on the old lamps, they didn't have that. They're both the same size. So you could plug them in either way. The new plugs don't allow you to do that. So what? Before you throw your lamp away, just go home, unplug it, turn the plug upside down or turn it around and plug it back into the outlet. What may be happening is you got what's called reverse polarity there. And what's happening is, instead of the electricity coming to the stem of the lamp, and then when you turn the stem, it's being released to the socket to light the bulb, what's happening is you're energizing the socket. So you basically have it backwards is what happens. Same thing can happen if your outlets are not wired properly. So if you don't, if you have something, maybe you get a poke off it or maybe a tingle off or something, and you look at it, and I got the plug that's got the big prong and the little prong to it. Well, you might want to look at your outlets at that point. So I'm going to, since I know kind of what I'm doing here with this, I'm going to stop this. This is something simple that you could go to a Meijer or a Walmart, go to the electrical section, and you can buy one of these. This is a tester for your outlets, and simply all you have to do is you plug it in. There's a legend on the back of there, and it will tell you if your outlet is wired properly, or maybe you have reverse polarity, or maybe it'll tell you that it's not grounded as well. And it's a simple thing. You can just plug it in, it will light up, and then it will tell you if something is wired properly or not. So if you ever have a suspicion that maybe something isn't wired properly, just get a little outlet tester like that. It's not expensive, and that will help you out. This is just another example here of reverse polarity. What I was talking about, just quickly, if I had things wired properly, like my one at the top, which is here, what's going to happen, my current is going to go to my switch. When I depress the switch, that will release the energy to my drill and to my chuck. It will do the work by spinning the chuck, and then it will go back to my outlet, where ultimately it will be grounded. If my polarity is reversed, what's going to happen is my power is going to go to the drill itself. Now, it'll still work, but what's going to happen is that drill is always going to be energized. So if I would, let's say it's a metal drill, say it's a little metal drill. I grab a hold of that metal drill, and I'm also in contact with ground. When I just grab a hold of that drill, I'm probably going to get a shock. So that's the danger of reverse polarity. I have talked about flexible cords, extension cords. Extension cords cannot be used for permanent wiring. They're supposed to be for temporary things. So I cannot plug something into, or not supposed to plug something into an extension cord and leave it there day after day, week after week, month after month. It is supposed to be for just temporary use. Now, flexible cords can be used for things like this, temporary things, like I want to plug in a light or plug in a fan or something like that. But they're not to be done like run through walls, run through ceilings, things like that, because that's really mostly a fire hazard. Because again, if that cord heats up, that building material is combustible, and we could have a fire. Don't have cords that are going to run through doorways, windows, and things like that where they could get damaged as well. And don't let your cords also create a hazard, trip hazards where they're going across, say, aisleways. This was a picture that I took not too long ago at a business. And as you can see in the business here, I have a electrical outlet, a box that is being dropped down from the ceiling. And so when you get closer to it, there's a close-up of it. And what you can see is the outlet has been pulled from the wiring or from the cable, and the wiring has been exposed. So that's one hazard right there. The other hazard is this was the metal box. And the metal box is supposed to be onto flexible wiring like that. It should be something that's non-conductive. And if you've ever looked at those, a lot of times you see a little spring that's on the tie. That's strain relief is what that is. What can happen is if I pull that box and pull that cord and bend it around and twist it and things like that, ultimately what can happen is without that strain relief on there, that wiring can get damaged and that box then can get energized. And then I'm holding that box, and that's grounding. We said grounding creates your path from your equipment to the earth. That's your protective measure. The number one OSHA violation is a grounding violation. And simply just something like what you see down here on the bottom. That is something that would be looked for, say, in an OSHA inspection. Look at cords, look at extension cords, look at cords that you plug in, make sure that ground prong is there. A lot of times that ground prong is a little bit longer than your other prongs, your hot and your neutral prongs. And so it gets a little bit more stress when it gets pulled in, pulled out of an outlet. So oftentimes those ground prongs can get weak, they can break out, or somebody comes across an area that is, they got a 3-prong cord and a 2-prong outlet. They say, well, geez, I can't plug it in because I only got 2 holes here to plug into, and they may on purpose remove that ground prong. So make sure that ground prong is there, because that is a violation, and that is a violation that is a common violation. This here, as far as the protective measures, one of the greatest things I think that have ever been invented is the ground fault circuit interrupter. And that's what you see here. You'll see these a lot of times, maybe around bathrooms or in a area where there's a sink. We got the little red and black button there. And what a ground fault circuit interrupter does is it measures the amount of flow or amount of current that is leaving the outlet to do work should be the same amount that's in the end coming back to the outlet to be grounded. And what happens is if there's a fault where we have leakage to ground going someplace else, that ground fault circuit interrupter will measure that. And within 1/40th of a second, it'll say, oh, we're losing current someplace, and it will click off just that fast. It's a lifesaver is what it is. So anytime that I have an area that's considered wet, a bathroom area, a sink area, maybe like there's a mop sink, like in a janitorial area, all of that needs to have ground fault circuit interrupters in it because of the damp, wet area. And on construction or in construction, if you're in construction, everything is supposed to be ground fault circuit interrupter protected. So what we have is either everything is supposed to be plugged directly into a GFCI, or they're plugged into what's called, what you have at the bottom here, a GFCI extension cord, which I can plug into a standard outlet, but will still give me the GFCI protection. So those are wonderful tools that are lifesavers. Overloaded circuits, plugging too many things into a circuit. For hazards, of course, we talked about that as a fire hazard. Damaged tools can overheat as well. We always want to look at our tools and make sure our electric tools are in good shape. Lack of overcurrent protection, I'll get to that here in just a second. That's our fuses and our breaker switches. So if we get into that, here's fuses and breaker switches. We'll start here with the fuses. Here real quick. So I am going to stop us here for just a second. Okay, so can you see me again, Deb? Am I still on the camera?
Yes, you're still on camera.
Okay. So some of you may have something like this in your home, a fuse like this. This is your overcurrent protection. So if you have older electricity in your home, you may still maybe see something like this. There was an old thing that people used to do when you would blow a fuse. You have maybe too many things that are plugged in, or something that was pulling too many amps, or maybe a malfunction. And what would happen is you maybe have a short circuit and it would pull a whole load of amps. It would be what they call blow the fuse. Well, there's a little fuse length that's in here. And what happens is that gets hot and that melts. And then what happens is you lose the contact. So your fuse doesn't work anymore. That's what they call blowing the fuse. There was an old solution a long time ago that people used to do. Maybe some of you have heard this or remember this term about putting a penny in a fuse. You can fix that by putting a penny in a fuse. Well, if you put a penny in a fuse, will it work? Yes, it will. However, here's the problem. You now have lost your protection when you do something like that. But now if you have something that's, say, malfunctioning and it's heating up, and now I don't have that overcurrent protection, you're inviting a fire is what you're doing, or maybe shock, but probably more a fire is what you're inviting with something like that. And to take this a little bit farther, if you would do something like that and it would end up being a fire, I'm pretty sure your insurance company would not pay for any damages. And quite frankly, you may be charged with arson in that case as well. Most of you probably have something like this, which are your circuit breakers. They simply act the same way as the fuses did if there's too much amperage there. Now, this is a 15 amp breaker. If there's too much that's going through, it'll simply trip off. Most people would go to their breaker box, they'll find which switch it is that's off, they'll reset it, and they'll continue on at that point. But if I have a switch, of course, that keeps tripping like that, then what has to happen is I need to investigate that. I got a problem somewhere. Too many things plugged in, functioning, or maybe just the switch itself is no good. I don't know how well you can see this, but the young lady that worked with me at one time here at the Safety Council gave this to me. This was one of her breaker switches at her home. It kept tripping off and she didn't know why, and she kept resetting it. Eventually it stopped working altogether. When she had an electrician that came in, what happened was it was a bad switch, and the switch, I don't know how well you can see that, but that switch is all melded there. And finally, it just malfunctioned completely and wasn't operating anymore, is what happened there. So if you have something that keeps tripping like that, and you don't know why, and you don't know maybe about electricity, it's best to get an electrician to come in and investigate that for you. Temporary lighting, I don't know how many of you have any things like the old bulbs like this, but maybe if you do have something like that, utility lights, those bulbs always do have to be protected from the damage that could be the breaking of the bulb. Some clues that electrical hazards exist. Those breaker switches keep tripping. Those fuses keep blowing. Something that's hot that's not supposed to be hot. So maybe like a faceplate on a switch that's warm. If that's warm, that's not supposed to be warm. You probably got a switch that's bad, or maybe something like you have a dimmer switch that maybe got wired up to that and it's not the right type of switch. Tools that are warm, things like that. That's a clue that you have a problem someplace. Your ground fault circuit generator keeps shutting off and you don't know why. It keeps tripping. I don't know why this keeps tripping. We have a problem someplace. So what you're plugging in, or your ground fault circuit interrupter, something isn't working right, and it needs to be investigated. Worn or frayed insulation, water or wire connection as well. Preventing some electrical hazards, plan work with others. So if there's electrical work that has to be done, try to plan that electrical work when it's at a time when maybe others that are non-qualified people are not in the area and they don't have any exposure to this. If I do have to work elevated and it's electrical, I always want to plan, how am I going to prevent, if there would be, say, a shock or a flash, how am I going to prevent myself from falling down to a lower level and having that secondary injury? Always isolate equipment from energy sources, lockout equipment as well, so that it is all de-energized. Don't have on any jewelry. Jewelry is metal, it's conductive as well, and avoid wet conditions and watch for the overhead power lines.
Hey,
In a
Bob,
wet condition, sure. Yes, ma'am.
sorry to interrupt, but we probably need to start wrapping stuff up. I know we'll share these slides
Yep,
with
I
our,
am almost,
okay,
I-
all right,
I'm almost done.
thank
Okay.
you.
So avoid the wet conditions at all costs, including things like wet clothing. We had a lot of humidity around Northwest Ohio this year. So avoid the wet conditions as much as possible. Always have the proper PPE on as well when you're working with electrical. Voltage rated hard hats, voltage rated gloves. You want electricians work boots. They have composite toe, not steel toe as well. So we always have the proper PPE on as well. Make sure that everything is wired properly, check switches. Always use 3-prong plugs so that everything is properly grounded as well. And in the end, make sure the equipment is listed, labeled, it's free from hazards, it's used how it's supposed to be used, and it is protected from shock as well. So that's the end of the presentation. I got just, if I can here, Deb, just a couple little show and tell things here, just real
Sure.
quick. Okay. So first of all, here, I picked this up along the way. This was an extension cord. Grab the other end of this here. This is an extension cord. This is homemade right here. So I got the plug, and then somebody has wired a box onto the end of this. So I have 4 outlets. The problem with this, of course, we don't have any strain relief here. So somebody may in the end wrap it up like this, carry it like this, and eventually those wires can pull out of there or become compromised. The box being metal, conductive, of course, now somebody grabs a hold of this, they come in contact with the ground, they'll get a shock from something like this. A metal box is designed to be affixed to a permanent structure. So that should be up against a wall or on a pole or something like that. This is here, that's my GFCI extension cord. So this is a wonderful tool. So I can plug this into a standard outlet and then plug a tool, let's say, into the outlets on here. Okay. And what that does is that gives me that ground fault circuit interrupter. So there's a wonderful tool for folks to have if they don't have a GFCI outlet. And still get that protection. Okay, so that's it. Now that's my presentation there.
Okay, great, thank you.
All
And then
right.
let me just go back to sharing my screen real quick so we can wrap up. All right. Thanks so much, Bob. You did a great job. I feel like I know, one, I'm not going to be getting in and out of my car when I pump gas in ever
Oh,
again.
Okay. Don't get
Um,
that. Right.
yeah, I just didn't know. I thought they just didn't want us to leave the pump, but apparently
Right.
there's more to it than that. So anyway, I hope everybody else gleaned what they needed to from that will be helpful at work and at home. Bob's contact information is up on the screen, and obviously I'll be sharing that via email as well. Again, we will be drawing for the $100 in chamber gift certificates after the meeting, and we'll share this information, and any questions you can always email me at dcats@lymanchamber.com. Our next meeting is August 10th at 8 a.m. Same bat channel, same bat time right here at Zoom. And we're going to be talking about COVID and OSHA. So I appreciate everybody being here this morning. Go about your day. Please be safe and stay well.
Thank you.
Thank you. Now, Bob, we did have one quick question.
Yes.
If anybody wants to stick around, you
Sure.
can, or you can leave. That's fine. Let me see if I can find it now. Okay, somebody wanted to know if there was a 15 amp outlet, or is it okay to have a 15 amp outlet on a 20 amp circuit breaker?
Yeah, you just can't go over. So if you don't want to have, say, a higher rated, say, fuse or something like that, you can always have less, just not more.
Okay, great, great. I think that was all the questions we had. So we're gonna go ahead and wrap it up for today. And I'll see you guys back here. Keep your eye out on your email and we'll let somebody know who wins $100 today.
Great.
All right, take care. Thanks again.